Hello everyone, welcome to my channel Physics Tricks. So let's start with work energy per DPP, and in this I'm taking the very basic questions for you, very basic questions you should know, right? So see here, this is the first question. Identify which of the following energies can be positive or zero only. So kinetic energy, as we know, kinetic energy formula is half mv squared, right? Now velocity, yes, it can be positive, it can be negative, it can be zero. But velocity squared, it must be zero or positive. Velocity squared, it must be zero or positive. So kinetic energy is positive value. So this is true, positive as well as zero. So it is possible. Potential energy. What about potential energy? Potential energy is m into g into h. H value depends on our reference. H value depends on our reference. If you go upward, h is positive. If you go downward, h is negative. And so the potential energy is. So potential energy positive, possible. Potential energy negative, possible. And potential energy on the reference line will consider 0 joule. So potential energy positive possible, potential energy zero possible, potential energy negative possible. So this is not the answer. What about C? Mechanical energy. Mechanical energy means what? Mechanical energy indicates the total energy, right? So total energy is kinetic energy plus the potential energy. So when the kinetic energy is zero, potential energy is equal to the total energy. So and we know that potential energy is positive, negative and zero. So C also not possible, and so as the D also not possible. What is the answer then? Only the kinetic energy. Only the kinetic energy has positive and zero value. So you have to remember. What about the potential energy? It might be positive, negative, zero. Mechanical energy, positive, negative, zero. Both kinetic and mechanical energy, no. Kinetic possible, but mechanical not at all possible. So B, C, D not at all possible. So second question. The total work done on a particle is equal to change in its kinetic energy. So total work done, we know that work done by external plus work done by conservative plus work done by non-conservative plus work done by pseudo plus work done by anything is always equal to what? Change in kinetic energy. So net work done is always equal to change in kinetic energy, and this holds true for everything. This holds true for everything. So change in its kinetic energy, it holds always true. Only if forces acting on the body are conservative, wrong. Only if inertial frame, wrong. Only if no external force, wrong. So it is always true. Do remember, it is always true. Total work done on a particle is equal to change in its kinetic energy. Okay. Work done by force of static friction. See, static friction, it might act in the direction of motion. Static friction, it might act in the direction opposite to the friction, right? In the direction opposite to the motion, right? How? So see here, if we consider block on block system, this is M1, this is M2, and this is mu1 we have, and this is mu2 we have, right now. So friction on M1, as these two blocks are moving with some speed supposed to be v, and with some acceleration also, right? Then what will happen? Right? So then on M1, if you see static frictional force on M1 due to M2, static frictional force will act in this direction, and on M2 static friction force will act in this direction. So due to this static frictional force, we have positive work done. Due to this static frictional force, we have negative work done. So yes, it can be positive, it can be negative, it can be zero also if displacement of the point of application is zero, right? So yes, all of these is the answer. So I hope this is clear. Next, work done when force acting on a particle takes it from point R1 to R2. So firstly, calculate displacement. What is displacement? Final position minus the initial position. So what is the final position we have? I hat minus j hat plus 2k hat minus what is R1 I hat plus j hat plus k hat, and if you just solve this, I hat minus j hat plus 2k hat minus I hat minus j hat minus k hat. So I hat cancel, it will become minus 2j hat plus k hat, right? And this is the displacement we have. We want what is called as the work done. Work done is a scalar quantity and it is the dot product of force and displacement. What is force over here? Force is I hat plus 2j hat plus 3k hat and dot with what is the displacement? Minus 2j hat plus k hat. And if you just solve this, you will get I, nothing is there, so 0, plus 2j minus j minus 2, it is minus 4, plus 3 and 1, it will become 3, minus 4 plus 3, it will become minus 1 joule. So I hope this is clear. So answer for this question is B. Now fifth one, a particle moves along the x-axis and from x is equal to 0 to x is equal to 5 under the influence of variable forces given. The work done in the processes. See, whenever work done by variable forces there, you have to use this formula F dot dx, right? So from x is equal to what? 0 to 5. So put F value 7 minus 2x plus 3x squared dx. So which is equal to what is the 7 integration? 7x minus 2 x squared by 2, that is x squared, minus plus x cubed by 3, that is x cubed, from 0 to 5. If you just put all the values, you will get 7 5s are 35 minus 25 plus 125. So what is the answer over here? Answer is work done is equal to 10 plus 125 is 135 joules. So these are the 5 simple questions. One bonus question I'm taking, and that bonus question is this one, right? So when force is applied on these two masses is connected by a string, right? It is massless string, and the force is applied on this massless string perpendicular to it. So after some time, right? After some time, the situation will be somewhat like this, isn't it? Situation will be somewhat like this. Due to this force F, we have the acceleration in this mass m, isn't it? Let us consider that acceleration along the x-axis is ax, because this mass m will have the acceleration along the x as well as along the y. That means there is a resultant, but we want only the acceleration along the x-axis. So that acceleration is ax. I am considering tension in the rope is t. And this angle, let us consider theta. So what are the components of this tension? See, tension, if this is theta, this must be theta, and this tension will have the component along this direction, that is t cos theta, and this tension also, this second tension also, plus t cos theta. So it is 2t cos theta. 2t cos theta must be equal to what? Force F. Okay, force F. Now who is providing this acceleration? It is the tension which is providing, and tension as pulling from mass, it is pulling from this mass, it is pulling, right? So we have this tensions, one component is providing the acceleration. So what is that component? If this angle theta, this must be theta, right? Now, so I hope all of you are understanding this theta. This is the tension. So tensions, which component? This tensions cos theta component is vertical and the sin theta component is horizontal. So this t sin theta is providing the acceleration. That means mass into acceleration along x-axis. Now see, if we have 2t cos theta as F, this is equation 1 and this is equation number 2. Now it's very simple, right? So we have tension T is equal to F divided by 2 cos theta, and over here tension T is equal to max divided by sin theta. Now just equate these two, you will get then F divided by 2 cos theta is equal to, right? Now T is equal to this, that means this term must be equal to this term, which is equal to max by sin theta. So from this, what is ax? Ax we have is F divided by 2m into, this is sin theta by cos theta, no? Sin theta by cos theta, which is equal to F by 2m. Sin theta divided by cos theta is tan theta. Now what is tan theta over here? tan theta, as you can see, this tan theta is, let us consider this length we have is x. So what is this length? This length is L we have right now. This length is L we have. Total length is given over there, right? That is 2L. So this length we have is L, right? So I hope this is clear. So this length we have is L. So this one we have is a root of ls squared minus x squared. Ls squared minus x squared. So what is tan theta? Tan theta definition we know, that is opposite side by adjacent side. What is opposite side? It is x. What is adjacent side? Root of L square minus x squared. So f by 2m into x divided by root of ls squared minus x squared. So acceleration along x-axis is f divided by 2m into x divided by root of ls squared minus x squared. So I think all of you understood this. I think all of you understood this, right? Okay. So now if anyone has any doubt, they can always comment in the comment box. I'll try to reply to your comment as soon as possible. Thank you so much.